Hello, I'm Shane in Sweden, and this is my series of videos on how to build an intrusion detection system using C# and Visual Studio. And as always, if you want to follow along with the coding, then just download the source code from the link in the notes under the video, and you can follow along and do the same coding as I'm doing in this video. In the last video, we started to set up the structure for reporting, and in this video, we're going to take that further. Before we do anything else, we should just run all our tests to check that we haven't broken anything with the work we did in our last video. And we can see that two of the tests have been broken. The first test here, I think this is because of the changes where we had a reporting agent added to the sensor. These use the original constructor, and thus they have no reporting agent. If we go to this test, I think we will find that this is the same. Yes, we've got a sensor without any reporting agent. And so when we come to sensor process next manage, when we come in this method, you can see we're perhaps getting a match, and then we're calling on the report packet captured method for the report agent that doesn't exist, and we're getting a null reference. So I think we should just need to fix this test right away. And if we run our tests again, because the way the constructor is at the moment, we don't actually need to have a reporting agent if we feel it's unnecessary. So we need to handle that scenario with the sensor class. And now our tests are green, so we can continue. Test-driven development, it's never a good idea to continue with new development as long as there's even one test which is failing. In this video, we're going to be extending the reporting properties, reporting to a repository, in this case an SQL Server database, and we will be connecting to that SQL Server database via entity frameworks. So the first order of business is to create a new database, which we will call alerts. And inside that alerts database, we're going to create a new table. And the table here, we will store all of our interesting alerts that have happened. So first of all, we will have perhaps an alert ID. And that will be of type identity. So we can set that as the primary key. And then for every incoming alert, we have the information we saw previously. So we will have data source ID, which will also be a GUID, which in SQL Server terminology is a unique identifier. And that will be not null because we have to have a data source. Then we have source IP, source port, destination IP, destination port. We also want to store the text of the message, so we'll have the payload, the date we captured it on, and I think that's everything we need. So we need to set the types for this. The source IP and the destination IP will be, let's make that 15, and nvarchar. Port numbers will be an integer. Payload We're going to keep this simple for the moment, so we'll keep that as an nvarchar. And we're only going to save the first 255 characters of every text message. And the captured should be a timestamp, but we can also have a date version, which is a date time. Okay, and none of these really should be, not null, but it's some types of events I can imagine where we don't want to save the payload. Okay, so we've got our database table, and we'll save that, and we'll call this also alerts. So we have our new table. We also need to do something else. We need to create a new project here for our data layer. Since we quite often want to add different sorts of data access, it's useful to have it as in a separate project. So let's add a new project. And this will be a class library. And we'll call it, let's just keep it simple, let's call it data. And we'll delete that. Now, in this data access layer, we need to install entity frameworks, and we'll do that through NuGet. And we're going to install the latest version of entity frameworks. So that adds entity frameworks to our project. And in both the Tyranids project, we need to add a reference to our data project. And even in our test, although we should create a separate test project here for this. So let's add a new project. This also needs to refer to our data project. Now in our data project, we're going to add a new data model. So we select new item, we go to data, and we choose ADO.NET entity data model. We will call this alert model. When you're accessing a database through entity frameworks using a repository, there's several ways to do it. One way is to do it code first. The other way is to do it from the database. So in code first, you actually design the classes, and essentially .NET works out the best way of persisting those entities down into the database. From the database first model, you're taking an existing database and it's creating a data model from that. Our project here is so simple, it doesn't really matter which way we go. Generally, depending on the type of project you're working on, if you're working on a legacy system, you're probably going to have to go database first. And if you're working on a new project, you'd probably go for code first. It seems to give better performance. But of course, there are a number of other issues. For example, the tables in a code first project tend to be harder to read and use from other applications. So if you've got several applications which want to come in and use the same database and are not using entity frameworks, then the database first model can work better. Well, these are design issues you need to look at as an architect when you're building your system. In this case, we're going to go for entity framework designer from database. And we have to make a connection. And we select Microsoft SQL Server. And we're going to connect to our local host using Windows Authentication. And then we need to connect to our database, which is alerts. We test the connection. And we will create some entities called alerts entities. And we're going to use Entity Framework 6 here. Now we really only have one table at the moment. now Visual Studio will create our entity framework data model with our table, our repository. Okay, so we're now going to work on our reporting, and here we're going to create a reporting agent which reports to an SQL Server database. But as always, we're going to start with a test. So let's create a new test, and we're going to call this SQL Report Agent Test. And we're just going to copy over the usings. So we need references here to our Ternet's project. And we need to install and substitute into the package. So let's go to our right project and install package and substitute. We also need to install the reference to the Visual Studio and unit package and unit assembly. So let's go into assemblies and under extensions, Visual Studio, quality tools, unit test framework. Okay, so we have our references in order. However, in this data project, we're not really working with report agents as such. We're really working at a lower level, persisting information to the database. So we shouldn't call this SQL report agent. We should call this SQL data agent tests. And this is, of course, a test class. And then we're going to create a test method. So in these tests, we're going to look at how we persist our data to the database, how we persist our data to the alert table. So we're going to test for fetching and persisting. So in our first test, we're going to test save. Save an alert. And successfully persist. And then we're going to use our usual arrange act and assert. So we can create a new alert object. We don't need to add an alert ID because we've got an identity column there. For the moment, we can have captured. Say captured to. We can actually take that from our test capture device. Created as equal to datetime.now. Data source ID. Create a new GUID. And let's change that state with Parset so that we can test for it afterwards. So if we go to our tools, We can create a grid, copy. We've got the data source destination IP. Is that equal to localhost, and source IP, we can set that to and the source port 28 and the destination port 34. What more do we need? We need a payload. That's equal to hello world. Red. So we have our alert, and then we need to add that to the alerts table. Okay, we need to add a reference to our entity frameworks, or we can just install the entity frameworks into the project using package console. And of course it helps if we spell it right, entity framework, not entity frameworks. Okay, so we have a reference to entity framework. We can see here. So using our entities, we can add our alert. And save changes. Now then we can read let's put this inside. So we want to get entities, alerts. We want to get the first that matches. Of course there is only one in the database, but that doesn't matter. We're going to want the alert where the data source ID is equal to, here we can copy in our WID. Basically we're persisting an entity down to the database, and then we're going to read it back. Here we're going to assert, for example, that our expected value is an alert. Destination port, for example, is equal to red alert. Destination port. And it should be the same for all those parameters. So if we say, for example, payload, okay, I guess that'll do for now. Now there's one final thing here. We have a problem. In unit tests, we want to be abstracted from our database, but when we're doing tests in the data layer, it's a different matter. Here we actually want to see that the data layer is working as we expected, so we can use the database. That's okay. Another important factor though when using a unit test is that you want the situation to be exactly the same after you finish the test as it was when you started the test, so that the order in which the tests are carried out doesn't matter. You can run the test multiple times. Now this is not true here, because here we're actually take an object, we're persisting it to the database. It will exist in the database, and after we've read, we won't be able to run this test again because we'll be creating a duplicate object with the same GUID, which either would not work at all, as we couldn't persist the duplicate, or when we run this again, we'll get an exception here because well, actually we won't get an exception because it'll fetch the first. This should really be perhaps more stringent if we say single. Now we would get an exception if we ran it twice. So we need some way around this when we're doing database testing in a unit test. The way we do that is, the simplest way to do it is actually using transactions. What we do here is we actually wrap the entire process, the entire saving and reading from the database inside a .NET transaction. The transactions are when you're trying to package a number of small work units together where everything has to go through. Either everything has to work or nothing works. A typical example is when you're transferring money from one account, say account A to account B, and the way you do that is, we're going to transfer $500 from account A to account B. Then you would break that up into delete $500 from account A and then add $500 to account B. Now obviously you do not want the situation where this piece of work is done and then the process crashes, so that account A has lost $500 but account B has not received it. We want to keep the database in a consistent state, and we keep it in a consistent state by combining these two into a single transaction. They either both work or they don't work. And at the end of that transaction, if we want to go ahead with the transfer, then we commit the transaction. If we don't want to go ahead with the transfer, then we abort or roll back the transaction. And we can do the same here in our test. So we can do another using, if we set transaction scope. And I'm guessing we need a reference to system transactions. And we're going to set it to a new transaction. It would help if we spell it right. Thank you. And then we can move our entire entity frameworks operation inside our transaction. So now we will actually persist our data, our alert, to the database. Then we will read our data from the database, and then we'll do our asserts. But at the end of it, we actually haven't done anything with our transaction. So if we wanted to complete the transaction, we could do that by saying transaction complete. But we're not going to do that. We're not going to do anything. And the default behavior then is that we have a rollback. And so the transaction will not be completed. And what will happen is then that all the actions, including persisting our objects to the database, they'll disappear. So I think we're ready to run this test. Okay, we have a problem here, and it said no connection string for the alert entities could be found in our application configuration file. So the application configuration file used by our test is here. And if we go to it, well, of course, we can see we don't have any entity information at all. So when we created our data model here, it was in the data project. So we just need to convert over and take that information and insert it into our app config for our tests. So let's run our test again. And if we look closer, we're getting a validation failed for one or more entities. Okay. So when we create our alert here, there's something wrong with one of the properties. If we compare with our database structure, we can see we've got alert ID, which should come first, but we don't need that because it's an identity column. And then we have the data source ID, which is a GUID, and then we have the source IP, which is a string. That's good. And a destination IP, which is a string. These don't go over the lengths. And then we've got the port numbers, and that's okay. The payload is string, and the captured is a timestamp. But instead we created our capture here with a byte array, which is a bit of a miss. For the moment we can just set that to null and run our test again. Here we get another error. Does not recognize the system GUID parse string. Okay, this is an interesting point in that in our query it will actually try to convert this to an SQL Server query function, which can have some side effects. So we're just going to take out that from the and now we can set that equal to the new alert GUID. So now if we run our test again, and we're getting green results. Now if we want to look at our transaction process here, we can. It's interesting to see what happens now that we're running inside the transaction scope. If we just set a breakpoint here, exactly after where we've saved our changes, and if we run this test in debug mode, okay, right now we've just saved this object that we created here to the database. And if we run the query, as you can see, the query just runs and runs and runs and runs without ever finishing. This is because it's waiting for our transaction here to be committed or rolled back. But we can look at the changes that are happening in the database right now. So if we set transaction isolation level, read uncommitted, then we can look at changes that haven't been committed yet. And now we can see the object that we've temporarily created in our database. If we go back to our project, our test, we even read that object from our database. So it exists in the database right now, and up to the point where we come out of the transaction here, you can see the object exists. Now we have left the transaction scope, and so an automatic rollback has happened. And if we look at our database now, there are no objects. The rollback has occurred and there are no objects in our table. So we can run this test as many times as we want. So let's just run all our tests again. So now we have our data layer sorted and tested. We know that we can save objects. We know that we can read objects from our entity framework repository. And it's time to implement that functionality in our report agent. But first we have to check that our tests are all green. And our tests are all green, so now we can carry on with new development. But actually I can see we're getting up to almost 30 minutes here, so it might be a good time to stop. So we'll close the video off here. Thanks very much, and I'll see you in the next part.